Welcome students. So this is the load test on single phase induction motor part 2 video. So in this video we are going to see how to do calculations after taking reading from the motor. Okay. So this is the reading we got. So if you see, we have measured the voltage and the current and the input from your wattmeter, all these three readings along with the spring balance S1, S2 and this speed we have measured using your experimental setup. Okay. Next, what thing we have to do is we have to see, calculate S1 minus S2, which is nothing but S1 minus S2. So I have calculated this thing, and then torque. So we all know that torque formula is S into R into 9.81. This we have seen for DC motor also, the same formula. So S is the slip, we have calculated from S1 minus S2. R is the radius of the brake drum. So in this experiment, the radius of the brake drum what we are using is 0.09 meter. Okay, so substitute R into 9.81. So 0.09 into 8.1 is 0.883 into S. So if you substitute these values, you will have the torque value as 5.4, 8.5 and 9.6. Okay. Then we have to calculate the output power. So output power we can calculate using the formula 2 pi. So 2 pi NT divided by 60. Okay. So this is 2 pi is 3.14, N is speed in RPM, torque which we have calculated using this formula divided by 60. So if we substitute all the values, I will have the output power as 844, 1313, 1470 watts. Okay. So then we have to calculate the efficiency. Efficiency is calculated by output power divided by input power. So 844.2 divided by our input power is this one 1240, we will have 68. Similarly 71 and 72. Our efficiency of the machine keeps on increasing. Okay. So with this data we have to draw the graph. Okay. So these are the two graphs you have to draw. So first one is your mechanical characteristics, which is speed versus torque, and second one is your electrical characteristics, which is output power versus the required quantity. So in our case, so this is our mechanical characteristics. So we have drawn along x-axis torque and y-axis you will have your speed. Okay. So like this you have to put the graph, normal graph what you do in the mathematics. So you have to write the scale, x-axis 1 centimeter equal to 2 Newton meter. So the unit of torque is Newton meter. So I have taken as 2, 4, 6, 8 and 10. Similarly in y-axis it is your speed. So it is 200 RPM. So if you have to plot, for example, you have to plot like this. For 5.4 torque, the speed is 1484. So for 5.4, the speed is 1484. Like this you have to plot and you have to draw a line. Okay, this is your mechanical characteristics. And this is your electrical characteristics, which is output power versus your torque as well as your efficiency. So in x-axis you have to take your output power. So in x-axis 1 centimeter is equal to 200 watts I have taken. So that is why 200, 600, 800 up to 1800 I have taken. Similarly y-axis is of two axis, y1 and y2. y1 I have taken torque and y2 I have taken as efficiency. If you see the scale for this one, in y1 axis 1 centimeter equal to 2 Newton meter. So 2, 4, 6, 8, 10, 12 I have taken. Similarly in y2 axis 1 centimeter equal to 10 percentage. So 10, 20, 30, 40, 50 up to 80. So you have to draw with the points which is taken from your graph. Okay. So torque versus power output is for 5.47, 844. So I have put on here 844 for 5.47. Like this you have to plot the point and you have to draw a straight line. So this graph depicts that when torque output power increases, our torque also get increased. And similarly for efficiency, so for 844 it is 68, 71, 72. So I have written as 68, 71, 72. So it follows like this, and if I keep on increasing it will start decrease. That we have seen in the DC motor experiment itself. So that's all about the characteristics, and you have to do the model calculation as you did for your DC motor. Finally you have to write the result. So the result is thus the load test on single phase induction motor is done and the characteristics were drawn. So thank you.